All right, so what we were doing on the previous page, or the first page of the notes, is we were finding what's called the area of the sector. So sector, and a sector is a part of a circle that's enclosed by two radii. So like a slice of a pizza, like a pizza slice, is a sector of a circle, or a slice of pie is a sector of a circle. And then we have an arc length of an arc, which is a part of the circumference. So the sector of the circle is a part of the area, and the arc length is a part of the circumference. So when we remember, when we talk about arc measure, that's degrees. But now we're going to be also talking about arc length, which is a distance. So we want to keep those two things separate. We want to keep track of, are we talking about arc measure or arc length, or in this case also an area of a sector. Remember, theta is the Greek letter that is used to represent an angle. So we have that central angle theta. We have radius r. And so now let's see if we can kind of generalize to a formula for this. Right? So really what we're thinking about is what part of the 360 degrees, what fraction of the circle. Now on the previous page we had some nice fractions. We had like a half of the circle, a fourth of the circle, a sixth of the circle. It's not going to always be so nice. So if we kind of think about where we got each one of those, why we divided by 6, 1/6, what we divided by 4, or multiplied by 1/4, it was really what fraction of 360. So if it was half a circle, 180 divided by 360 is a half. If it was a fourth of a circle, that'd be 90 out of 360 was a fourth. And then we would multiply that times the area. So it's basically just what fraction of the area. Fraction of the whole area. So the pi divided by 360 gives us the fraction of the circles, and then the pi r squared, of course, is the area of the circle. And the same thing works for the length of the arc. Think of, okay, what fraction of the circumference? So pi out of 360, so we call this, not pi out of 360, theta out of 360 times the circumference. Either pi d or theta over 360 times 2 pi r, if you prefer to think of circumference in terms of a radius. So fraction of the circle times the circumference for the length of the arc. So what part of the circumference are we talking about? So let's go through each one of these and let's figure out the shaded sector area and the length of the arc. Okay, so let's see if we got this. All right, so we got, think about this kind of in the way that we did the other one. So 270 out of 360 is 3/4 of the circle. Okay, so for both the area and the circumference, we're going to be thinking about 3/4 of the circle. So for the sector area, we're going to have 3/4 times pi r squared. So 3/4 times 100 pi, which then is going to be 75 pi square units, or approximately, I think I calculated 235.6 square units. And then if we think about the arc length, that will be equal to 3/4 of pi times diameter, so pi times 20. So 3/4 times 20 pi, so 3/4 of 20 would be 15, so 15 pi units. I forgot to actually get the decimal for this one, so let's see if we can quickly do that. Here I could split screen, but let's just see if we do this. So 15 times pi. 15 times pi is about 47.1. Okay. Units. And so, by the way, we're talking about this arc length right here because we're talking about that 3/4, that 270 degrees part. So not the white one, but the blue one. Okay, let's do that same thing for the next one. So we got a slightly less enticing fraction here, but we got 135 degrees out of 360. If you're good at reducing fractions, then we'd see that 45 goes into 135 3 times and 45 goes into 360 8 times. So if we want to think about it as a fraction, otherwise you can just multiply by 135 360. Or get the decimal as well, that would actually work. So the area is going to be, the area of the sector is going to be 3/8 of pi r squared, so pi 16 squared. So 3/8 times, okay, 16 squared is 256. And 3/8 times 256, so if you take 3 times 256 divided by 8, you get 96. So 96 pi units squared. So you might have to do just this little bit here. You might have to do a little work, but that's just 256 times 3 divided by 8. And that's where you get the 96. And that's approximately, if I multiply by pi, about 301.6 units squared. So that would be the sector area. All right, let's go ahead and get the arc length. And again, I'm referring to the arc length here. So arc length will be 3/8 of the circumference. So pi times diameter would be pi times 32. So 3/8 times 32 pi. Okay, so 3/8 of 32. Okay, well 1/8 of 32 is 4. So, 32 divided by 8. So 1/8 of 32 is 4, so 3/8 would be 12, right? 12 pi. Or 3 times 32 divided by 8 would be 12. So 12 pi units. Should circle this one over here. Okay, and then 12 times pi, so that's going to be just a little bit over 36. All right, so 12 times pi equals 37.7 if we're rounding to the 10th place. Okay, so there you have sector